Good morning, everyone. The topic of my data communication FA-II is multiplexing and demultiplexing in satellite communication. This is a presentation by Samiksha Mote, and I am from Division P. The first things first. We are living on the Earth, right? For communication purposes, we have multiple towers, cables set up all across the Earth. But in the space, there are no such cables, there are no such towers. Have you ever wondered that how are NASA and ISRO scientists and other space organizations able to communicate with the outer spaceships or the astronauts in the space, though there are no towers or cables in the space? The answer to this question is these giant antennas. These antennas are set up by NASA in all the seven continents in the world. These antennas are over 230 feet tall and with high frequency from the ground station to spacecraft communication has been made possible. As you can see in this image, suppose that an artificial satellite is placed in the Earth's orbit. Consider this as the Earth's orbit. Now, from the Earth, some signals will be transmitted to the satellite. This process is called as the uplink. This satellite will process these signals and will send back signals back to the Earth. This process is called as the downlink. Now, here's the problem. There are many users trying to send data at the same time. TV channels, phone calls, internet data, all through the same satellite. So, how do we manage this? That's where multiplexing and demultiplexing come in. We'll discuss about this communication process later on, but first, let me explain about modulation. Some signals, that is the signals that we want to share, these signals are firstly fed into a multiplexer. Now, what is a multiplexer? Multiplexer, or MUX for short, is the process of combining multiple signals into one signal. These input signals are fed into this multiplexer, which combines it into a composite multiplexed baseband signal. This baseband signal is then sent to a modulator, as you can see there. A modulator. The modulator processes the composite signals along with a high frequency carrier signal generated by a carrier oscillator. So, originally, these signals are in a very low frequency, converted into one single signal, and these are fed into a modulator. These signals are then fed into the radio frequency power amplifier, and which strengthens the transmission power of these signals, which amplifies it, which is strong enough for transmission. These signals are later on transmitted to an antenna as electromagnetic waves. These waves carry the information to the receiver end. Next, multiplexing and demultiplexing in satellites. As I said, the signals are first fed into the multiplexer, later or into a modulator. So, uh, multiplexing is a key process performed at the Earth station before transmission to the Earth via the uplink. This multiple independent information streams, such as television channels or internet data or voice communication, are first modulated individually using appropriate digital modulation schemes. Schemes such as like FDM, TDM, CDM. There is then this resulting signal, baseband signal, is up converted to a carrier frequency in the microwave band, and then it is amplified and then transmitted to the high gain parabolic antenna towards the satellite. This satellite then receives the signal and applies down conversion and amplification through the low noise amplifiers and retransmits it onto the different downlink frequency back to the earth. Now, the problem is here. When these signals are received by the receiver, these are still in combined signal forms. So, what happens is that's where demultiplexer comes into the story. Deep multiplexer is the reverse process of multiplexer. Once the combined signal come down from the satellite, the receiver, like your television box or satellite modem, it splits the signal back into individual channels or data streams. So that's how you can flip through different television channels, even though they come from the same signal. What are the benefits of this multiplexing and demultiplexing? So they allow multiple users to share one satellite channel. Bandwidth is used more efficiently. It reduces the cost of transmission and it helps satellite support television, internet, GPS, and voice calls all at the same time. In conclusion, so to wrap it up, multiplexing and demultiplexing are like traffic managers of satellite communication. They first organize multiple signals into one for sending them, and then that is again split apart on receiving, which makes it fast and reliable and efficient for modern day communication. So that's the end of the presentation. Thank you.